I'm Todd Wieland, and I'm really happy to be here to talk to you about remanufacturing and its connection to sustainability and circularity. I'm based in the U.S. I lead the global R&D team, as was mentioned earlier. I've got excellent colleagues in India, and I know that they will be able to continue the conversation with you on this. But what I'll be able to do is provide a little bit more of a global and historical perspective. But now we support alternate fuels and more recently electric and hybrid powertrains. In order to do that well, it requires a variety of components. These are complex systems, and so you can see the list of component types on the right-hand side there: filtration, fuel systems, after treatment, and understanding those and integration of those effectively has enabled us over the last decades to reduce particulate and NOx emissions by over 96%. If you think about it, that's a tremendous reduction in the emissions level of these products. And for NOx, we're now even supporting a further 10x reduction. So this is very significant. And then on top of that, right, there's a shift already happening toward electrified power. And there are some applications like urban bus where that makes sense, that is economic sense right now. And that shift will continue as the technology improves. Well, you can see the numbers there to give you an idea of the size of Cummins, about $24 billion last year. I'm also glad to be part of an organization that really emphasizes corporate responsibility in really three areas: education, a little bit more about also commitment to the environment, and that I know that this comes from the heart of our leadership, and it's really been part of our history. We are organized in those 5 divisions, as you can see down at the bottom. Let's put some numbers to that now. We're in about 190 countries, 60,000 employees. Last year, we built over 1.4 million engines. We largely own our distribution. We spent about $1 billion last year. We started in diesel in 1919 and remain headquartered in Columbus, Indiana. We've also been remanufacturing for a long time, over 50 years, and we support all those same markets where Cummins supplies new products. Let's take a look at the products. There's a whole list here, but let's look at those a little bit more. So engines. We remanufacture engines. What's the context there? A couple. One, there could be a failure, a catastrophic failure, where it makes economic sense to swing the whole engine instead of repairing it. Or there are other applications like a mining truck that will easily consume 4 engines over its lifetime. And so now we're not just talking about remanufacturing kind of as an option that a customer might consider at some point. For some applications, it's absolutely expected to support that high value asset over its life cycle. The other kind of things you'll see, cylinder heads and turbochargers, connecting rods, those will be parts typically used for an overhaul. Let's say the truck is at midlife, the engine needs to be refreshed, and so this will be an overhaul event, and those components then would be replaced. There are others in here, like a fuel system, a fuel injector in the lower left. Those are small, but they're high value, high precision, tolerances on the order of microns. They tend to have significant surface engineering, specialized coatings. And these things have, a tough life. They're operating, 17 hertz, operating well above 2,000 bar pressure, and they might need to be refreshed at some point during the life of an engine. And so those make a very good remanufacturing sort of candidate. And then in the lower right, you're starting to see some newer products, transmissions, automated manual transmissions, as well as electrification hardware. Those images are for very large batteries, but there'll be other components as well, traction motors, power electronics, that will be remanufactured as well. We do this around the world. The red circles represent our remanufacturing plants for our smaller products. The core is returned, we call that reverse logistics, right? Where that core that used the old product has to come back. We've got reverse logistics core centers around the world represented by the black circles. That's sort of the collection points then for the core that is then shipped back to the remanufacturing plants. The larger engines, of course, are heavy, and the transportation is expensive. And so we tend to handle that more on a regional basis near large populations of engines, and those are represented by the blue circles. We've been remanufacturing in India now for about 10 years. We've got an export plant in Pithampur, where we produce both heavy duty and high horsepower components listed there. We also have a domestic plant on the Cummins mega site in Fulton, a couple hours away from Pune. And there again, we're focusing on the heavy duty and high horsepower components. Those are supporting both the India Parts Distribution Center as well as the high horsepower engine remanufacturing center. Rajiv provided a nice overview of the process steps. I'll go through those real quick again, but highlight a few of the technologies that we've developed along the way to facilitate that. I mean, the first point I'll make is, again, this is a factory-based process. These steps are typically occurring on a small line as opposed to some benchtop process. But it begins with disassembly. And you can appreciate that these products are operating for a number of years in environments where they may be exposed to road grime or other sort of dirt, can be some external corrosion. And so simply taking them apart can be difficult. And so we've automated and applied some technologies to facilitate that. Next is cleaning. You know, the same challenges are part of cleaning as well. We've got aqueous methods, thermal methods, even molten salt methods to reduce the corrosion, the residual sort of oils and greases, the dirt. And the technique that you're seeing down below there is laser cleaning, a wonderful process. The laser ablates whatever the debris is, and because the clean metal underneath has higher reflectivity, the laser doesn't keep going, but stops once it's removed the debris from the surface. The next key step is inspection. We have to establish that the now clean core doesn't have conditions that would interfere with its next service life or that require repair. And so we've got various optical and other type methods to inspect the core. Next comes restoration or salvage, and there's a variety of things that we do there. There could be mechanical means for inserts, sleeves, bushings. Then we've got material addition technologies, thermal spray to build up worn surfaces, or more structural methods, traditional welding, or more advanced welding, like as in effectively laser deposition, where again we can build up that worn surface, and because we can choose the material often, the resulting surface actually can be better than the original. Right? If a cast iron component was the original part, then that wear surface is cast iron typically. Well, here we can choose something that's even more wear resistant, and so arguably the remanufactured product is even better than new. And then finally, we've got the assembly and testing step, where we will typically use a version of the original process. We certainly have and apply the original specification, and then we can apply the same or similar test method as well. So why does Cummins focus on remanufacturing? maybe another time we can talk more about the history of remanufacturing within Cummins, but I'll say a few quick words about that here in a moment. On the left-hand side, though, from a customer's perspective, availability of remanufactured products reduces their total cost of ownership. The next slide will dig into that a little bit more. From a Cummins perspective, it helps us manage and support the customer over the life cycle. Early in life, remanufactured products may be used to service warranty. In the middle of the life cycle, we may have the competition coming on the scene. What we call those will fits, value, price, then remanufactured products can help meet that need. It's same as new warranty, same as new performance, same as new sort of global sales and support, sales and service support, but at a value price. And so that gives those customers exactly what they're looking for. Then late in life, it also helps us support our customers once the original suppliers, due to the loss of volume for that particular part number, may become expensive or may be not so interested in continuing that supply, right? So remanufacturing can help us support the tails of the life cycle. And we'll support our products, for literally decades, right? We would still remanufacture various components for 40-year-old engines. Increasingly on the right also is the connection of remanufacturing to environmental sustainability, and we'll talk more about that in a second. So first, from a customer perspective, what's the value proposition for remanufacturing for fleets and others that are very sensitive to uptime? After all, this asset is used to earn a living, right? And if it's down, being repaired, well, then it's not making money for the customer. And so swinging an engine or swinging that major component with a remanufactured one is just faster, and it's a way to get that asset back to work. Because it's a factory process to the original specifications in our case, the customer is also confident in the quality, right? So this is a factory process, and the core terms vary a little bit around the world. Maybe we'll get to that a little bit in the Q&A, but the idea is we make it simple. Purchase the product and return the core. So at the bottom line, the graphics at the bottom help illustrate then the process. That core is returned. We're able to apply original factory methods. We've got the original factory specifications. We apply advanced technology, supplement with genuine parts, and produce that very high quality product. Okay, let's start to pivot a little bit toward the sustainability and environmental perspective using some numbers from India. First, in the upper left, easily 75% of an engine can be remanufactured. We've got lots of high value iron and steel castings and forgings that are good candidates for remanufacturing. Going all the way to the lower right, over the last years in India, we've recovered over 10,000 tons of core, producing over 500,000 different units shown there in the lower left. Okay, so what difference does this make? Well, first of all, bottom center, this takes a lot less water compared to the extraction and processing of ore and making new castings and forgings. So we think we save 150,000 kiloliters of water every year. And water matters to us. We operate in water challenged areas, and we know as we think about the future that water will become increasingly one of those constrained resources. The other thing is that not having to recover that ore and reprocess castings and forgings saves a lot of energy, with the result that there's less greenhouse gas emitted. There are a variety of studies, by the way, with varying degrees of material reuse that describe or that help validate some of the numbers that you've been seeing. I think Rajiv mentioned a 50% sort of energy savings in the one case, and there are other analyses that show that number is even higher. Okay, um, continuing our pivot towards sustainability. Cummins is just finishing up a decade of largely meeting or exceeding sustainability goals relative to our own operational footprint. By that I mean the waste that we produce in our facilities, or the emissions from those facilities, or the energy consumed by those facilities. But as we look to the future, we recognize that, okay, we have to continue to do a good job there, but even more. And so here we've got inputs to the planning that was done recently for the updating of our sustainability plans, and you can see them there, right? And some of them you can appreciate maybe firsthand. So pollution is a growing concern. Climate change is real and it's happening. We get extremes of weather, flooding in one case and drought in another. And population is growing, and along with that growth comes increasing waste, and then also just in general resource consumption. And we anticipate that we have to decouple, or society needs us to decouple population growth from resource consumption. We just can't consume at the same rate that has been done historically. So what did we do with this? First, let's talk about our 2050 aspirational targets. They're really in three groups. At the left, we've got the goal of communities being better because we are there. That's a significant statement. Sure, we enable employment, but there's also impact in the community or in the environment locally, and so our goal is for the net effect of our presence to be positive wherever we're operating. And in the middle, we've got to do our part to address temperature rise to, say, 1.5 degrees Celsius. Then what we have to do is back calculate what the transportation contribution to that is, and therefore what reductions we have to make in our product portfolio to support, limiting that temperature rise to, again, whatever the scientific consensus is. And that's what we mean by science-based goals in a more absolute sense. But what I'll talk most about will be the third category there, resource stewardship, using materials in the most sustainable way. And so by 2050, we want to say, look, nothing's wasted. We design it out in the first place from products and processes, or we use it again. And again, we see water, the idea of using what we need, but returning it clean. Talking about 2050 is fun. Some of us won't be here, or at least not working on it. But closer to home, we've got some 2030 goals. Again, in sort of the three groups. At the top, we've got those climate-related goals that I talked about. At the bottom, we've got some of those waste-related goals. But in the middle is the idea I want to talk about, and that is creating a circular life cycle plan for every part, to use less, use better, use again. I was the advocate for this concept of the life cycle plan for every part. It can be difficult to convince a designer to prepare for remanufacturing. They may ask, well, how do you know you're going to reman that? Or what will the volume be? And those are reasonable questions. But on the other hand, we have to be more thoughtful if we're serious about these kind of goals at the front end of the product design, and say, hey, what's the plan for this product? So it seems to me that that's a reasonable starting point. And then oftentimes, remanufacturing will be part of that plan and answer. So what does this really look like if we talk about a life cycle plan for every part? I appreciate already the discussion of the various R's, but I'll talk about them a little bit again. If we're talking about reducing, then obviously we can use optimization tools to only put material where it's needed. And modern computer tools enable us to do this quite effectively. And we can choose material and processes wisely based on the planned usage cycle. If, let's say, there's a gasket that's really going to be replaced at the time of service, well, then that doesn't have to be designed for 1,000,000 miles, right? On the other hand, that major casting or forging does. We can also produce less manufacturing waste in the beginning using additive manufacturing. In fact, we're doing that now already. So that is 3D metal printing to support legacy parts when perhaps, as I mentioned, the original supplier is no longer available. Okay, well, when the customer is first using the product, we're in the reuse and repair sort of mode, and so for that case, we want to make sure those wear points are durable or readily replaceable. Sometimes an insert or a bushing is all you really need to protect that more expensive casting or forging. But then at the end of the first use cycle, then remanufacturing would be relevant, and the idea there then is to design those high value components to have sufficient life for multiple use cycles. We'll want to plan for the material replacement, make sure the methods are available, defined and validated in anticipation of the remanufacturing. And at the end of the multiple use cycles, when we get to the end of life for that particular product, then we're in the recycling mode. And there we'll want to plan for material separation. That can be one of the challenges for recycling. And then be thoughtful about how we do it. For commodity materials, irons and steels, probably makes sense to plan for recycling of those locally. However, for constrained or more strategic materials, it'll make sense to recycle those centrally. And in fact, extract those materials and return them to our supply base. And we're doing that now with exhaust system components, for example, that have platinum group metals. Last year, I think we returned about 1 million pounds of those. Wrapping up here, let me reinforce first about what remanufacturing is on the right-hand side. So again, I think we've already seen this quote from the ANSI Reman standard, which is available via the link shown at the bottom. But the point here is this is a complete, it's a comprehensive industrial process. That previously worn product is returned to a like new or better than new condition, and that's going to be warranted. For us, it's going to be at the same performance level and the same warranty as a new part. So we are restoring the expectation of a full second service life. Could be second or third, fourth. It's not a limited scope repair. It returns a saleable product to commerce, typically sold to a different customer. It's a product, not a service. And then importantly, it retains the embodied energy. We're not reducing the material to its to the sort of raw level. So you can see on the left the various material loops. You see the sequence of operations to produce it originally. You see the original sort of use cycle where we're repairing and reusing. Next comes remanufacturing. And then finally, ultimately, we get to the recycling stage. I do want to comment briefly. I do appreciate the end-of-life vehicle sort of perspective. There certainly is a place for that to help a society sort of upgrade the sort of emissions capability, determine whether any of those castings for the major components are still relevant for newer products, or even to support the others that will remain, and sort of extract those before that vehicle is destroyed at end of life. But in summary then, remanufacturing is good for the customer. Same as new performance and superior value. It's good for business. It helps us support our customers over the life cycle. And increasingly, it's good for the environment and part of our strategy for good stewardship